Sir, your mic is off.
Good morning, everyone.
Yes, you are sir, audible and visible clearly. Sir, you can show your presentation if it is there, so we can check it.
Okay. Yeah.
Good morning, Ghare sir.
Good morning.
Welcome you, sir.
Thank you. I'm just trying to load my PPT.
Yes, sir. A very warm good morning to one and all present here. My name is Manisha Savlani. I am an assistant professor of Department of Applied Physics, Priyadarshini College of Engineering. It gives me an immense pleasure to extend you a very warm welcome on behalf of Department of Applied Physics, who has clubbed all of us together for this online multidisciplinary short-term training program on updations in teaching, learning techniques and research. For today's session, I welcome Mr. Hemant Ghare. Let me introduce you, sir. Mr. Hemant Ghare is associated with National Cancer Institute as a Chief Medical Physicist and Radiological Safety Officer, Level 3 since 2015. He has pursued his MSc and Diploma in Radiological Physics from Baba Atomic Research Center and Mumbai University. He has an experience of over 23 years in field of radiation oncology and medical physics. Mr. Hemant Ghare has published more than 25 national journals of medical physics and radiation oncology, and the list goes on. For today's session, Sir will be sharing his knowledge and his experience on the topic radiation hazard and protection. We welcome you, sir.
Good morning, everyone, and thank you very much for my introduction. And I'm very sorry because I am suffering from pharyngitis, so you may get some disturbance. But I will try my best to continue my presentation smoothly. So, can I start now?
Yes, Yes, sir, sir. please. Yes, sir.
Yeah. So, today my topic is radiation hazards and protection.
So your mic is off. Sir, your mic is off. Sir, you are not audible. Your mic is off.
Sorry, is it okay now?
It is okay now, sir.
Yes, sir.
Yeah. So, we'll go through the overview. Today we'll go to see what is radiation, then different forms of electromagnetic radiation, then what is ionizing radiation, then sources of ionizing radiation in hospitals, then sources of radiation in environment, which is we call it the background radiation, then the biological effects of this ionizing radiation, then objective of radiation protection, and what our government regulations to handle with this radiation. So government regulations and those limits, and then personal radiation monitoring and area monitoring. So as everyone knows, radiation is the emission or transmission of energy in the form of waves or particles through space or even through the material or medium. The radiation energy in the form of electromagnetic wave is called as electromagnetic radiation, and they are of two types. One is non-ionizing radiation, and one is ionizing radiation. So here you can see the different forms of electromagnetic radiations which we come across in our routine. So frequency starts from 10 to the power 6 hertz to almost 10 to the power 19 hertz. So low frequency region, you know, the radio waves, then mobile waves, microwaves, radar, infrared, visible, ultraviolet, X-rays and gamma rays. So this is the spectrum, and here you can see till visible and till some part of ultraviolet. This radiation we are termed as a non-ionizing radiation. But once the energy increases, here you can see the energy of 4 into 10 to the power 9 electron volt. This is the energy spectrum where it starts interacting with our biological structures. So here we term as it ionizing radiation. You can see the different forms of electromagnetic radiations. Say, in microwaves, mobiles, daily we are using the our remote control. So these are the different forms: microwave radiation, radio waves, ultraviolet radiation. We are receiving directly from the sun and the atmosphere. Then what exactly this ionizing radiation is? Ionizing radiation is nothing but a radiation of sufficient energy to displace or remove electrons from the atoms and molecules of any living cells or any non-living things and produce ions. So here in this slide you can see if neutral atom when interact with this ionizing radiation, either it loses its electron or it will gain one electron. If it loses electron, we will get the cations, that is positively charged ions, and if it gains the electron, it convert into anions. So any radiation with energy between 10 electron volt to 33 electron volt and greater than that is termed as a ionizing radiation. Here again the classification of this ionizing radiation is electromagnetic radiation as well as the particulate radiation. Now we have to see where do you encounter ionizing radiation in hospitals. Whenever you will go to hospitals, visit any hospitals and all, you should know where this ionizing radiation exists. So in general, there are these three sites: radiation oncology, mostly it is termed as radiotherapy. Here, linear accelerators, CT simulators, and HDR brachytherapy units. These are different equipments which are used for diagnosis or radiotherapy treatment. So here you will come across this ionizing radiation. Then diagnostic radiology, this mostly everyone knows, the CT scan machines, mammography machines, digital or fixed X-ray machines, sorry, mobile X-ray machines, C-arms, and other different equipments. And apart from these two, nuclear medicine, where open sources are used, such as PET CTs, PET CT, low dose therapy sources, high dose therapy sources, etc. Here you can see in radiation oncology or diagnostic radiology, mostly these are the non-sealed or sealed sources, or mostly they are the X-rays. But nuclear medicine, you have to take more care because they are all radioactive elements and they are open sources. Then you can see the sources of ionizing radiation in environment, or mostly it as a term as a background radiation. So even if you are not in vicinity of any man-made radiation, such as in any department where radiation sources, man-made radiation sources are there, even if you are not there, if you are in the local residential area, still you will be exposed constantly with this ionizing radiation. So some ionizing radiation is present naturally everywhere in the environment, known as background radiation, and we all exposed to these sources of radiation, which are usually in small quantities, say 2.5 millisieverts per annum. Here you can see man-made radiation is almost 19%, and these are other percentage. Natural radiation, mostly it's coming from the radon, earth crust. Then you can see the different amount of radiation we receive from cosmic radiation, that is from sun and other outer space. Everyone in the, whether he is in urban or anywhere in the world, mostly in this range zero point 0.4 millisievert yearly will receive this from cosmic radiation. Then terrestrial radiation contributes a bit more, which comes from earth crust. It is zero point 0.5 millisievert per year. Everyone receives this amount. Then radon, which is again in the earth crust. This is comes from decay of uranium and radon. This contribution is more 1.2 millisievert per year. And internal, even our body consists some radioactive elements such as in our bones, or calcium 40 is radioactive element. So from everyone we get zero point 0.3 millisievert per year. If you go and have a handshake with other person, you may get some ionizing radiation from his body. Maybe that amount is very negligible, 0 10 to the power minus 6 microsievert level. But still we, or everyone is also a source of ionizing radiation. So this data comes from Unscare 2000, and they studied the Hiroshima and Nagasaki bomb blast, and this Unscare is the dedicated society. They got the information and they find out the amount. So background radiation level vary geographically due to the geological differences. Exposure in certain areas can be more than 200 times higher than the global average. If you see for our India, you can see if you go to the area in the Kerala side, most of the beaches are thorium beaches. So if you go and stay in Kerala, you will get more radiation. Even in the Himalaya regions in northeast area, you will get more background radiation compared to the central India, maybe from Nagpur or central part. So more than 60 naturally occurring radioactive materials found in soil, water and air, which gives us this background radiation. Now you can see, I just want to know, can you see this image clearly on your screen?
Yes, sir, it's visible.
Yeah. So here you can see the drastic increase. At sea level, you can see only 0.03 microsievert per hour. This is the dose rate, and it goes on increasing. At high altitude, you can see it up to 10 microsievert per hour. So whenever you go fly from plane, mostly the frequent flyers will get more background radiation as compared to the citizens. So these are the different exposure level. At Himalayas, this is 1 microsievert per hour. So this is the distribution of this. Then we'll see the biological effect of this ionizing radiation. Everyone knows our body is made up of different type of cells, and each cells here you can see have chromosomes. From nucleus you will get chromosomes, and in the chromosome the different genes are there, and the genes contains DNA. So this DNA is the important part which generally gets damaged due to the ionizing radiation. In this picture you can see the photon, means maybe X-ray or gamma ray or any ionizing radiation. It will knock out the electron and it causes the radiolysis of water. Water means H2O. It will get um, dissociated and OH radical is formed. Here you can see, and this will go and damage our DNA. This is the indirect action. Another direct action is photon will knock out electron. Is electron directly go and hit the DNA and it will damage. So DNA in chromosome gets damaged due to this ionizing radiation. The biological effect of this ionizing radiation. Ionizing radiation thus causes changes to human cells. As you can see, the DNA directly gets damaged. The change can be fatal or detrimental to your health. Then two type of effects generally observed. One is the stochastic effects, means it is as a probabilistic effect. Means we don't clear cut tell that this amount of radiation will cause this amount. No, we cannot define any minimal dose level below which our cells are safe. So this is a stochastic effect, and this is a probabilistic. Depends upon the amount of radiation. If amount of radiation increases, the chances of these effects increases. So stochastic effects means cancer or genetic effect, and deterministic effects are death, skin burns, cataract, or infertility. Means for these effects, a certain amount of radiation dose is confirmed. For example, for infertility, if a human being receives 6 millisievert or more than 6 millisievert, then he or she become infertile. Or a particular amount of a known amount of radiation dose may cause cataract, and same like the skin burn. And death occurs means if too gray of whole body exposure of ionizing radiation, then the person may succumb to death. The biological effect of ionizing radiation on living cells may result in three outcomes. So we'll go to see these three effects. First is cells die and are removed through normal biological process. This we are using in the radiotherapy. So we give a defined amount of radiation to the cancer cells, and due to that amount of radiation, slowly all these cancer cells will die, and patient will cure from the cancer. Second, cells incorrectly repair themselves, resulting in biophysical mutations and replications, which results in disease such as cancer. And in some instances, injured or damaged cells are able to repair, resulting in little residual damage. Thus, ionizing radiation can do death, cancer, skin burns, cataract, infertility, genetic effect, etc. So, here everyone should know that whenever you are coming across the ionizing radiation, you should be very cautious and you should know each and every aspect of this radiation. So, that's why our objective of radiation protection is one is to prevent the deterministic effects, because deterministic effects means they have some certain amount of radiation. If we will prevent this exposure, then definitely everyone is safe, and limiting the probability of stochastic effect. Because if you are using this ionizing radiation in different fields, anyway the persons using this radiation or the persons for whom they are using this radiation, they have to receive some amount. So we should limit this amount of radiation so that the probability of the stochastic effect should be very low. So the three principles of radiation protections are justification, that is no unnecessary use of radiation is permitted, which means that the advantages of advantages must overweight disadvantages. Second, dose limitations. Each individual must be protected against risk. Sorry. Each individual must be protected against risk through the application of individual radiation dose limits. We will see this in our next slide. And then optimization. It means making every reasonable effort to maintain radiation exposure as far below the dose limits as practical, taking into account economic, social, and other considerations. Here we called it as a ALARA principle, that is as low as reasonably achievable. And these are the three principles of radiation protection. These everyone should know. Time. So reducing the time of an exposure reduces the effective dose proportionally. This is specifically for the radiation worker those who are working in different departments. They should spend very less time with the radiation sources. And even if they have to do the work, try to stand much away with distance. So distance, increasing the distance reduces the dose due to the inverse square law. Double the distance, you can see, reduce the dose by 1/4 time. and it will triple the distance, is reduced as the dose by 1/9 times. So whenever this is specifically we are telling to the anesthetist or the nursing staff, they are just assisting the procedure. So if they will stand much away, their radiation safety will be assured. Sorry. And the third is shielding. Shielding can reduce radiation doses. The shielding materials are concrete and lead shields, which is 0.25 millimeter thick for secondary radiation and 0.5 millimeter thick for primary radiation. Now, the principle for radiation protection for the internal exposure. We cannot apply time, distance, and shielding once the radioactive material is inside our body. Hence, preventing loose radioactive materials from getting inside the body is the most important means of control of internal exposure. So, isolate the contamination at, at the source. Seal sample, use a fume hood, use catch tray lined with paper, change gloves often to avoid cross contamination. So, these are very small, means very few points I am including here because I just want to focus on the other aspect of the radiation. Then establish and maintain the contamination control zone. Follow established laboratory procedures, proper protective clothing, design designated work areas, surface contamination monitoring, personal monitoring, etc. are required in all laboratories and use that uses radioactive materials. Sorry. So now in India, there is a regulation, and these are the two different institutes who look after the radiation safety. One is the Atomic Energy Regulatory Board, which is situated in Mumbai, Anushakti and the Department of Atomic Energy. So, no dose limitations for medical exposure of the patient. It is always assumed that the benefits for the patient outweigh the risk. So, if there is an accident and some urgent CT scan is required, and if we will apply the dose limits for the patient, then we cannot go for the that procedure itself, because in other next slides you can see, just for example I am telling at this time, suppose a dose limit of 20 millisievert is there for a general for a radiation worker, and if the same radiation worker has to take CT scan, so during single CT scan he or she will receive more than 20 millisievert. So that time we cannot say no, the dose limit for the radiation worker is 20 millisievert. So you don't, he or she is not allowed to go for a CT scan, because CT scan itself will give more than 20 millisievert. But then if we will not do the CT scan, then it may create a lot of problems, and that may cause a death also, or any, because of lack of any treatment he or she may get any problem. So when the diagnostic or any in radiotherapy, if it is required to save the life, then these dose limits cannot be applied. So that's why here it is, there is no dose limitations for the medical exposure, but limits need to be applied to the public and occupational exposure. Government regulation in our country, the Atomic Energy Act 1962 and Atomic Energy Radiation Protection Rules 2004, promulgated under the Act, forms the basis of radiation safety in India. And Chairman Atomic Energy Regulatory Board is the competent authority to enforce the regulatory provisions of Atomic Energy Radiation Protection Rules 2004 for safe use of radiation sources in our country. It is statutory requirement to obtain below mentioned approvals from Atomic Energy Regulatory Board for safe operation of equipment. So if anyone want to set up any diagnostic setup or a radiotherapy center, any hospital want to start any facility which will use ionizing radiation, they should get a type approval of that machine, then type approvals of equipment, layout approvals are needed, sorry, then type approval of equipment, then license and registration of operation, and periodic quality assurance. So Government of India through Atomic Energy Regulatory Board, they will check all the requirements. If any of the requirement is not available, then the head of the institute or the licensee uh, has to face the regulatory actions. So these actions may be in the form of imprisonment or any heavy fines. So controlled area as per AERB safety code, the radiation symbol for radiation generating equipment such as medical diagnostics X-ray equipment, industrial X-ray radiography equipment and accelerators shall have a warning sign as illustrated in this picture. Here you can see the central part is showing X-ray tube and the radiation is coming through the X-ray tube, and caution X-ray, Savdhan children, and so as per the different states, the local language, in local language also you have to mention this. So whenever you will come across such type of symbols, you should be very cautious. X-ray warning symbols to warn and control access to radiation area. Then the radiation symbol for radioactive sources. These radioactive sources mostly use gamma rays other than medical diagnostics and industrial X-ray radiography equipment is illustrated here. So such type of symbol you might have seen in, mostly in Hindi pictures or in TV serials, but this symbol is very rare, specifically in the hospitals. So trifold radiation symbol to warn and control access to radiation area. And apart from these two signages, we have to put such type of warning lamps so that there should not be any unauthorized entry. Now most important is the dose limits. So here you can see occupational and public. Occupational means all the radiation workers. So their effective dose should be 20 millisieverts per year. Averaged over 5 years means within 5 years he or she should not cross the 100 millisieverts. And for public, 1 millisievert per year means whenever general public come across any radiation facility, uh, the radiation facility means the radiological safety officer or department will take care of the public, and the radiation zone is managed in such a way that even if there is a presence of any general public, the radiation level will be less than 1 millisievert per year. And these are the annual equivalent dose limits for other body parts. Lens of eye should receive less dose, 150 millisievert dose. Skin should be below 500 millisieverts and hands and feet below 500 millisieverts. For general public it is less. For lens it is only 15 millisieverts. For skin it is 50 millisieverts. With further provisions that dose in any single year less than 30 millisieverts and 50 millisieverts as per ICR. Now, once we set the dose limits, there should be some means for the proof that yes, really these dose limits are followed. So there are personal monitoring is available. For personal dose monitoring, we have to use thermoluminescent dosimeters. As you can see in this picture, it is a badge we have to wear for particular period. And these are the passive radiation detectors. These are the chest badges and these are the wrist badges. Mostly in nuclear medicine or in the department where mammography is used, the person has to use this wrist badge because the chance of getting irradiated of his wrist or hand is more. And other radiation worker will mostly use this chest badges. TLD badges are received regularly by for quarterly periods. At the end of each service period, there are 4 service periods. January, February, March is the first service period. Like that, it is divided into 4 different service periods. And at the end of each service period, these CLV cards are returned to the personal radiation monitoring service lab for processing and assessment of the doses received by the person. The dose records of all individuals monitored by the service labs are uploaded to National Occupational Dose Registry Section (NODRS), Radiological Physics and Advisory Division (RPNAD) of Bhabha Atomic Research Center, Mumbai, which maintains the lifetime dose records of each radiation person monitored. Then this type of personal radiation dose monitors are also available. Pain dosimeters and chargers, TLD rings, shin badges, and electronic personal dosimeters. And personal dosimeters are assuring the doses of the radiation worker. But then the general public, um, those who are in the vicinity of these facilities, to assure their exposure levels, they have to use this area monitoring. So these surveymeters are used to detect leakage radiation of the X-rays and gamma rays. So outside the X-ray room or outside the radiotherapy department or outside the nuclear medicine department, we are going and doing these surveys, and this survey should show that the radiation levels are much below of 1 millisievert per annum. That is whatever the dose limit set by the regulatory body, and that should be below that. If the doses are higher, then you have to do something. There might be some flaws in the layouts or maybe in the, but generally this not happen because before initiating these services, one has to take the different type of approvals. So when we take the layout approval, here we will take care that even if a maximum exposure is happen in that room, there will be no radiation outside the particular room. Then here you can see this type of survey meter. These survey meters are used to detect contamination at radiation at nuclear medicine departments. For different particles such as alpha, beta, neutron, different detectors has to be used. All survey meters are required to send to authorized laboratory for periodic calibration and certification. So ARB not only controls the facility or the equipment or quality assurance, they will take care of the survey meters and monitoring also. So because everything should be calibrated and traceable to the national level or international level. The ionizing radiation has served the mankind many-fold than any other scientific invention in the form of medical, industrial, agricultural applications, and scientific solutions. And we should use following key factors to provide maximum radiation safety in the institute where different radiation sources are used for diagnosis, treatments, and other peaceful purposes, which are awareness, preparedness, and detecting equipment. Thus, radiation is totally safe if handled properly. Thank you. So, if
Thank you
any
very
question,
much, sir. The panel is open for discussion. Participants can raise their questions or queries. Okay, considering that nobody has any queries or questions, so we thank you. Thanks a lot for taking out time for this event and sharing your knowledge with us. Sharing your PPT in very colorful way. It helped us a lot. Thank you very much, sir.
Thank you. Thank you.
Thank you so much, Hemant sir.
Thank you, Mr. Satish.
For further session, I would like to tell that further session will be carried out by Pooja ma'am. I hand you over the session, ma'am.
Thank you so much, ma'am. Good morning, everyone. I'm Pooja Nichar, Assistant Professor, Department of Applied Physics, Priyadarshini College of Engineering. I'll be introducing our second speaker, Dr. Sumita and Rao. Ma'am will be joining us shortly. Ma'am is a Dean, Academic, Priyadarshini College of Engineering. Okay. Stay connected. Ma'am will be joining shortly.
सर्वज्ञ नेक्स्ट वाला लेना अभी यूट्यूब लाइव, ठीक है, नेक्स्ट सेशन का। शुभम, नेक्स्ट सेशन का यूट्यूब लाइव लेना है।
Ma'am has joined us. Welcome, ma'am.
Good morning, ma'am.
Welcome, ma'am. Good morning. I'll be introducing ma'am. Dr. Sumita Rao, ma'am, is Dean, Academic Priyadarshini College of Engineering. She's an Associate Professor at Department of Applied Chemistry. Ma'am is having a teaching experience of 22 years and research experience of almost 30 years. Dr. Rao has research publications in 41 international journals and 3 in national journals, and also has 3 patents. Dr. Rao has presented papers in 21 international and 11 national conferences. Talking about the achievements, Dr. Rao has successfully developed a research laboratory in Department of Applied Chemistry by grants received through industrial projects and consultancies. Also, ma'am has guided students in developing various entrepreneurial skills in projects such as Bujayate, which comprised of replacing plastic bags with cloth bags made out of used clothes, thereby emphasizing on principle of reduce and recycle. Briskly, instant fabric stain remover, and Harit, herbal mosquito stain repellent. So without any further ado, ma'am will be today delivering her talk on advances in wastewater treatment. So ma'am, you can start now.
Thank you, ma'am, for your wonderful, kind words of introducing me, ma'am. I'll be talking on advances in wastewater treatment because that is one of the most important topic that we need to address in today's world, looking into the scarcity of water. At the outset, I would like to thank all the organizers for giving me an opportunity to be a part of this STTP and giving me an opportunity to share my views with all the participants that are present here. And this is, I feel that this STTP is a mode wherein there can be exchange of ideas. Even the speakers, they come to learn many new things when they discuss with the people, because we all agree. I'm so sorry. we all agree that you all are teachers. You may be knowing more than me, but because this is my field, I have decided to give a talk on this advances in wastewater technology. So now, with the permission of the organizers, I'll share my slide. Is it visible to all?
Yes, ma'am.
Okay, thank you so much. So this is my okay, so this is advances in wastewater technology. Now we all know the importance of this particular topic. There is scarcity of water nowadays, and none of the industries or for domestic purpose, water is a very, very important commodity. So looking into the present scenario, the water that is being used in industries or for domestic purpose, can it be treated and can it be reused or recycled? Keeping that in mind, I have chosen this topic. Now we all know the different types of pollution that are there. I need not stress on this. The different types of pollution are, we have water pollution, we have air pollution, we have solid pollution, and several other like noise pollution, health pollution, radioactive pollution. So many pollutions are there, and the result of all these pollution is ultimately public health. Ultimately, it is the public health that is being compromised because of all this pollutions. And apart from this, we have economics. Now, like I told you, I'm going to concentrate on wastewater. So wastewater are also of different types. We have sewage, we have institutions wherein the canteen is there. So wastewater is generated from there. Labs are there. Wastewater is generated from there. Industry is no doubt the major source of wastewater generation. Then commercial establishments are there, restaurants are there, so many places are there. Even in agriculture, the wastewater is generated. So there's not even a single source where we can say that the wastewater is not generated. All the sources, in some form or the other, generation of wastewater is there. So I'm going to concentrate on industrial wastewater treatment. Now, we know there are different types of industries, and different types of industries generate different types of wastewater. Now, depending upon the industry, we will have the pollutants and also the concentration of pollutants. So we cannot say that a single treatment process can be applied to all industrial wastewater. The technology will depend upon the type of pollutant that is present in the water, and it also will depend upon the concentration. Even if the type of pollutant is same, the treatment process may vary depending upon the concentration, and also what is the quality of water that is required. There also wastewater treatment, the technology depends on that. So treatments, there is a combination of physical, physicochemical and biological process. So like I told you that we have to apply all the three process or two processes. Now, before we go into the different methods, we need, first thing that we need to know is the physical, chemical and biological characteristics of wastewater and what are their sources. Before applying the treatment method, we need to know these characteristics, and we also need to know the source from where the wastewater is being generated. So under the physical, we need to know the color, odor, solids and temperature. Under chemical, we need to know the pH, dissolved oxygen, fats, organic compounds. Under organic compounds, again, we have various types of these. Then heavy metals. Biological, we need to know the types of bacteria, microbes, and the sources, like I already have discussed with you, will vary from domestic, industrial, agriculture, and natural. Now, what are the different wastewater treatment technology? Now, like I told you, the technology will depend upon the type of wastewater, and it will also depend upon the concentration. Okay, so treatment technology is waste specific. So normally we apply 4 levels. Normally, the first, primary, secondary, tertiary, and quaternary, out of which primary and secondary is common. That is applied to all the sources of water. Tertiary and quaternary, they are polishing the wastewater. We call them as polishing the effluent. Okay, with respect to heavy metals, if it contains, so we need to reduce the concentration of heavy metals. And if it contains color, so to what extent the color has to be reduced. So tertiary and quaternary treatment levels, we call it as polishing of the effluent. The primary treatment, as I told you, primary and secondary are common. So primary treatment normally deals with removal of suspended solids, oil and grease, and secondary treatment deals with the removal of soluble matter. That is reduction in the levels of COD and BOD, that is chemical oxygen demand and biological oxygen demand. Now, before I go into the details, I want to tell you all, my dear friends, that the water contains oxygen in dissolved form. And this dissolved oxygen is very, very important for aquatic life. Now, when the wastewater is discharged directly into this the source. So what happens? The organic compounds that are present here, the contaminants that are present here, they use up the dissolved oxygen. They use up the dissolved oxygen for its oxidation. As a result of which, what happens? The level of DO comes down in water, thereby affecting the aquatic life. That is why it is very, very important to treat the water before it is discharged into the source, because the organic impurities that are present there, they are really very, very harmful for the aquatic life. I hope I'm audible and my this PPT is also visible and it is clear.
Yes, ma'am.
Okay. So now let us come to the different types of treatments. The first that I told you, primary and secondary, is compulsory. So the first one is the physical. So physical brings about physical change in the properties. The term physical itself, we call it as a physical treatment because it brings about the physical change in the property of contaminants, that is pollutants present. So it deals with physical treatment, deals with the various methods that are done in it are sedimentation, filtration, evaporation, and gas transfer. Now we all know these different methods. Sedimentation is done for the removal of suspended solids. Like I told you earlier, that the primary treatment deals with the removal of suspended solids. So suspended solids are removed with the help of sedimentation. Oil, grease, and other fine particles are removed with the help of filtration, evaporation, or gas transfer. So these all deal with the removal of which impurities, suspended solids, oil, grease, and other fine particles that are present in the water. Now, if anybody is interested in knowing how sedimentation is done, how filtration is done, that we can discuss it later on. Now, the second one is physico and chemical. It is a combination of physical and chemical process. So here the first process that is done is coagulation and flocculation. Coagulation and flocculation. Coagulation is done for the removal of colloidal impurities. Like in the first one, we have removed the suspended impurities. Here, this colloidal impurities will be removed, and these colloidal impurities will be removed with the help of chemicals. That is why we are keeping it under the category of chemical process. Then again, we have a process of adsorption, wherein we will be using some adsorbent for removing the color or for removing the other solids that are present here. Ion exchange, precipitation, membrane technology. Membrane technology deals with RO, that is reverse osmosis, electrodialysis, and the most important of all is oxidation reduction. That is advanced oxidation. This is very, very important, and it is a cheaper process as compared to the membrane processes. Now, just to give you an idea about how chemical precipitation is done, this is just first, this is the wastewater is introduced into a container. The pH is adjusted, and then the chemicals are added, and then those chemicals are normally the coagulants. Like FeSO4 is one of the major coagulant, ferrous sulfate or alum is added along with some additives if required. That can be lime, depending upon the quality of wastewater. Then it is stirred for a certain period of time to allow the reaction to take place, and then whatever sludge is formed, that is allowed to settle down. So that sludge is nothing but the organics that are present in the water. They are removed, and then this is the wastewater that is that has been treated. It is then discharged from here at the top, and the sludge is removed from the bottom. Now this is just a schematic diagram of reverse osmosis and osmosis. We all know the process of osmosis, and we also know that the reverse osmosis is just the opposite of osmosis, wherein pressure, external pressure is to be applied for doing the osmosis process. In osmosis, what happens? The water flows from a lower concentration to higher concentration. Whereas in reverse osmosis, in wastewater, pressure is applied. You can see here. You can see this particular diagram. I hope my cursor is visible to all. This pressure is applied to concentrated solution, that is your wastewater, wherein the concentration of salts is very high, and this process is normally done to decrease the concentration of suspended solids or dissolved salts. Okay, so now these concentration, it is applied here, which flows from here to here. So this process, normally RO process, is done in the presence of this semi-permeable membrane with the help of a high pressure pump. Now, this is the biological process. We have discussed physical process. We have discussed physicochemical process. Now this is the biological process. In this biological process, it is the microbes that play a major role. It is the presence of microorganisms that use up the oxygen, and they eat up the organic material or the pollutants present in the water. So here the decrease in the level of pollutants is done with the help of microbes. And this biological process also plays a very, very important role in treating the water. But here, biological process can be applied only to those effluents, wherein the ratio of BOD, that is biological oxygen demand, to COD is greater than 0.4. If the BOD to COD ratio is less than 0.2, then biological processes cannot be applied to that particular effluent. So the most important thing is it should be greater. BOD to COD ratio should be more than 0.4. Now, the most important biological process is activated sludge process that is normally used in industries. Activated sludge process in which this is the wastewater which is introduced into the grit chamber wherein we are removing the grit present in it, and then this is your primary sedimentation, that means your primary process is being done, and then it is introduced into a aeration tank where it is aerated with the help of air, and it is here where the microbes are introduced. Microbes are introduced, and then here microbes are reacting with the organic pollutants, and those organic pollutants, they are getting converted into CO2 and H2O, and the other sludge is formed, and that sludge is then introduced into the settling tank. This sludge is recycled back, because this sludge, a part of the sludge is containing some microbes which are still in an active form. So part of it is returned back to the aeration and a part of it is then after a certain cycle, that sludge is introduced into the solid waste management system, and then we have the final treated effluent. So this is the most common biological method that we call it as ASP, that is activated sludge process. Now, there are so many processes that can be used for the treatment of wastewater, but which is the best suited method? Like I told you, we have different types of wastewater, and no wastewater. You cannot say that all the wastewaters, this technology can be applied, because I have already told you earlier, because it will depend upon the type of contaminant present in it and also the concentration. So how do we select? What is the criteria for selecting the appropriate treatment technology? The criteria is wastewater characterization. We need to first characterize it based on the physical, chemical, and biological. And then we also need to know, once we have decided, okay, this is the technical method that can be applied, but whether that technical method is economic there, and whether it is following, that particular industry is following all the safety, reliability, and operability factors are available that in that particular industry before you select. Before first you have selected the technology. Now when we tell to the industry that you have to apply this technology, we have to consider all these factors. And once all these factors are considered, then we first do it in, we tell the industry people to first carry out it in bench scale, then pilot scale. And once that is done, then we can go it for commercial scale. So many processes are there, and then performance evaluation is very important, because in lab scale we will be getting good results, but we do not know whether when we apply it in pilot scale whether we are getting the same results or not. Sometimes it's what happens in lab scale and pilot scale, you get the comparable results, but we have to see in commercial scales also you are getting the same results. So the technology, the selection of technology is also very important, which I would like to tell you through this flow diagram. This is how it's done. These are 4 types of wastewaters: Class A, Class B, Class C, and Class D. The wastewater is characterized into 4 types. Class A is toxic, non-biodegradable. Class B is toxic, biodegradable. Class C is less toxic, and Class D is absolutely non-toxic. So how do we do it? Okay, first what we do, this is the source treatment testing. In industry we have different points from where the wastewater is coming. So we need to see whether the wastewater can be treated at the source or not. And then when we treat it, we assess it, bioassess it, whether it is toxic or not. Okay, upon bioassessing, if we find that it is toxic, then we recommend it for certain modification. And if it is non-toxic, then we can again go for another treatment, that is confirmation treatment. Again, bioassess is done. Similarly, when class B, that is toxic and biodegradable. Now we know here that here it is non-biodegradable. We know that because we have already performed some test on it. So we cannot recommend any biological process for it. We have to go in for chemical process. Now here we know that it is biodegradable. So again here we perform some biological treatment process in batch. We assess the biological whether it is toxic or non-toxic. If it is non-toxic, fine. If it is toxic, again we have to give them certain modification. We have to make certain modifications in the process that we have already done here. Okay, now